Yo, what up, what up? Hey, Noah. Yeah, I got my new DC motor in the mail, and we can do that today. That's cool. There's more than one way to make things spin, and I'm happy about that. Well, it's kind of all the same way. It's just you can buy one at the store if you want. That's really how I started doing stuff. I started on a DC motor, stacking discs that I built together, kind of like magnetic gearing, but just using the magnetic fields in different orientations to do that. It's pretty cool. You can check it out on my community page. It's experiment levitating on a pole, experiment 1 and 2. I'm just checking out the different effects that the discs have on their different orientations. There's a middle disc that's just kind of levitating there. It's pretty cool. Check it out. I'll be right there. All right, I had to check something out real quick, but thanks for sticking staying tuned. Whatever we have, what we're trying to do right here is just get this coil to trigger. I think we got it that time. There's only 9 volts going through it, so let's see if we turn it up a little bit. Gyro is going nuts. I love this one. It goes so fast sometimes. Let me see if I got everything hooked up right. Yeah, it looks like it. We got a little bit of the lights are illuminating. I don't know if that's a good thing. Let's see here about this load. There we go. That's what the problem was. It's not grounded. Red, yellow. Huh. Is that no? Yeah. So the load on this one is not hooked up somehow. Let me see. That's alright. It's not really what I wanted to do today. I was starting off with the SG circuit. I mean The reed switch side of things is working out just fine, and that's over here. That little dome right there. Hold on, I gotta close the door. Both doors, how about that? Okay. So, oh yeah, and I got my DC motor. So before anybody like gets, there is a motor underneath here. And yeah, I'm using it to spin this rotor and this turbine. So we can get the turbine going at a decent speed. We can get up to like 15, 16 extra DC volts. That's legit ready to use from this turbine up here. And then any coils that we'd like to put around this thing. This might be a little bit difficult doing it here. And the problem is there's a piece of wood under here. And it's in the way of me putting it like closer to the middle. This right here, nah, I don't think that'll happen. All right, so here, let's turn it on and see what happens. 3 volts. 4.41. So what's going to happen is we're going to tether the top down with a multimeter. See, because if you look, it spins without this part spinning, but it's really like there's a little bump there that if you don't like tether it somehow, it's going to sync with the rotor. But if you tether it, then it spins like a turbine, and you get your energy. Man, I'm glad I never got married. I mean, I love her to death, but man, she spared me. All right. What it does is it eases my mind. It soothes my mind, therefore it is useful and practical. Okay? Yeah, I bet if I hooked it up, maybe, with some sharp blades, it didn't weigh too much, I could cut grass with it. Yes. Maybe even this one. Yeah, thanks, bruh. You the man. Appreciate that. So cool. All right, so let's get that tether made up. I want to see how much energy. It says it's a 75 volt one. It can generate up to 75 volts. I don't see that happening. I do not see that happening. Where'd I put the dang meter? There it is. Now I'm going to clip these to the white wires, and it's going to give me the voltage reading. And then if I want to connect it, this is positive, this is negative, of course. See, man, maybe I can get a pole, and like put a pole here and like wrap it around the pole like this. That's what I'm gonna do. I'll be right back. It's right over here. That's only 6 volts in too. That's pretty good for how big those magnets are. All right, it is very magnetic. Go ahead, ask me. Do I mind jerry rigging? Do I mind doing it this way? Not even a little bit. We just need to keep it up off of the, I don't know if it's going to work though. Because now we got to plug it in. It's probably just going to slide right down the pole anyway. But hopefully having it off to the side will. Alright. I wish it was illuminated. I wish. DC volts. Alright. We're going to start off nice and slow. That's 2 volts. $369. Wow, what a number to stop on. 9 volts being generated. .6 volts in. 14 volts being generated. All right, let's see if it's all good. $18. 19. 25. Woo! Maybe if I turned it all the way up to 12 volts, it would go. Wow, man, that's awesome. Thanks, Chris. Yeah, man, this little thing is awesome, man. That was 25 volts of like usable DC electricity that I could, plug these little wires and hook something up. Should I do that? Yeah, man, This is awesome. And I had this hooked up in the middle, and I got a video made. I didn't post it though. Should probably do that. Where I was using the pulse motor to run the thing, and it didn't come anywhere near that, but it was pretty cool. Having the pulse motor run the turbine, that was sweet, actually. See, the thing about that one I just showed you is that you can hook up coils out alongside of it too, along with the turbine. So that, I don't know, that exponential gain right there. Chris Hatton, come on down, you the man. This is I would call it reverse SG. It's SG, but it's on the other end of the coil. It doesn't come first; it comes last. So it's not SG. And it probably might even work better if I would hook it up the other way. But I'm waiting for my batteries to get here, and then I'll hook it up. I'll hook it up, and we'll see what's going on. I got 2 lead acid batteries coming in. SLAs. They're little baby ones though. It's 12 volt, 9 amp hours. It's little baby ones. Yeah, man, that's gonna be fun. We'll set up some throwback or flyback relays or whatever they're called. Where the loops. And all that stuff where you're throwing the energy or one battery into the next, and you're using the spikes from the collapse of the coil to charge the batteries so you don't run out of energy. But I don't know if this is true. If it hits every single time, it's guaranteed to work. But I don't think you're guaranteed to hit every single time. I don't think you're guaranteed to spike every single time it collapses. At least not, well, I don't know. I don't know. I've had experiences where it's like kind of on and off. It might be my coils, honestly. They're real small compared to what I usually see. So, like this one is not triggering at all. I might have to redo this circuit right here. And then my light is not lighting up. I mean, we are only 6 volts in. That might be what the problem is. Usually none of that stuff even starts working until I get up to like 12, which is like 0.7 amps. Because I'll hit this reed switch one over here that's also hooked up to an SG. Alright, we're at 12.5, 0.7 amps. That one will start going pretty fast eventually. It's like the energy coming out of these coils right here, these two 20 gauge coils, is the SG end of this thing is not strong. I guess the back EMF part of it is not strong. The part that's running these, I don't know, maybe this will work though, jacking it up to 12.5. Yeah, you can hear that click go faster now. It's this one I'm really worried about. And the light is illuminating. It's starting to light up a little bit, but is it working? I can't hear it working. I mean, I think it's working based on the fact that it hasn't stopped yet, but I don't know if it has enough momentum to keep going. This one is definitely working. I'm pretty sure if I put that one, if I swap the two, that one would work here like really good too. It would be good. This circuit is good. And it's been good since I put it together, so that's good. I don't know what's going on with this one. Maybe this one it is the coils, but I've worked with this motor, you know, over here. Huh. Just looking to see if my diodes are right. And they look right to me, yeah. Huh. Just making sure nothing's touching anything else. That sounds like it's going right now. Maybe it was a... No, it doesn't, for some reason. I don't know. It's alright. I'm pretty sure it's just the SG. Like this light bulb is really bright, and this light bulb is not as bright. So one of these circuits is not hitting, like they're not hitting the same. And they should be hitting the same. Because of how the magnets are arranged. No. I could make it into one though. No, you could use the same concept philosophy, but it doesn't have the generator part of it hooked up there. And it's really only like very few amount of coils for an Adams motor, like 4. Then I guess you could mirror image it. And like a segment in the coil would go like right here. And you know, if I actually wanted to make a motor that has a schematic, I would definitely look at it first before trying to build it. That's just common sense. So I would have to say no, it's not an Adams motor. It's Papa Bale's Pulse Motor, and this is Pulse Motor Mayhem. Welcome. So what we got going on here is each one of these circuits, each one of these coils has a circuit over here on the board. It's a reverse SG, and what I mean by that is the power goes in the coil first, and then out of the coil and into the circuit. So the circuit's on the tail end of everything instead of in the beginning, in the front. I do have hookups for having the circuit in the front, or the front and the back, kinda. So I'm gonna look forward to hooking that up in the near future here. That's gonna be cool. Now, what? This is, I don't even know if I should have brought this out here. Might be the resistors fried. I don't know. I can't really tell what's going on with this. Let's see if, and the light's not working either, so this is not functioning at all right now. Even though the light's lighting up a little bit, I don't see it as functioning, like, at all. Even though the light's lighting up, which is really weird. I think that's just a residual from the magnet spinning past the copper. It's not from amps or anything like that. I wish I could just see what's wrong with it. That might be it. That might have been it. We'll see. That was it. Oh yeah, here we go. Crossed wires. It happens so easily right now. I'm hoping that it'll happen less and less and less. I love this one. How fast this one's going. I love this one. This one's awesome. And our new addition to the group here isn't even a pulse motor. It's a DC. I don't even know whether it's brushless or brush motor. I think it's a brush motor. It's really sweet. It gets that thing going really, really fast. And we'll hook up some coils around there. Hey Mike, what's up my man? Right there, that little cross, the plus sign with the big ends on it. Right here. This thing, and this is a turbine that I got hooked to the shaft. So let's just take another look at this. We'll turn it on DC voltage. That's 5 volts in. It's a 12 volt motor, so I think it will go up to 75. $25 volts, 26. Gotta find some, I gotta mount it. I gotta mount that motor. But yeah, man, that was like 28 volts. This is a DC motor. I'm not gonna take it apart right now, but there is a motor under this rotor alone. Only this one. This right here is a gyroscopic pulse motor. You need to turn the voltage up to get it to go gyroscopic though, and I can't do that because right now that thing's about to fly off, and we're only at 12 volts. It needs to be at like 35 for it to gyro. All right, so what I will do just to see if we can't get it to gyro. I'll turn this up a little bit. $13.5, 1 amp. Yep, it's starting to move. Oh. Man, I'm sorry, I'm moving the camera away. Dang, I don't think it's gonna get over that hump though. Not at this rate. I could push it. There it is. It's going. All right, sweet. Moving. So they're pulse motors and they're DC motors, and it all runs on this power supply or these two power supplies right here. There's 13.7 and 1 amp going into it right now. All my lights are lighting up. There it goes. Yay! Let there be light. It's flashing really bad right now, though. Heck yeah. The way I see it is at 12 volts, that thing's going to be going about 3,000 RPMs. I haven't gotten one of my motors here to run over 1,500 or 1,700, so my definition of a win is right there. If your goal is to see what happens when it goes above 3,000. All the lights are illuminated. We're at 14.1 volts, 1.2 amps. $15 volts, 0.3. And the lights haven't even barely started to light up here on the circuit board. But we're above threshold. I've been told that this circuit is about a 1 amp, 12 volt circuit, and we are above that by a lot. We got major vibration in the shaft. I'm gonna turn it down. Those bearings pop out, man. This thing's gonna fly off the shaft like no tomorrow. Oh, that's so cool. I'm glad this one's decided to work. Oh yeah. Do we want to try and hook anything up to the turbine? Besides the multimeter? Alright, so you know what we'll do is we'll hook up. I think I'm going to hook up this to the turbine. Because it's a reed switch, it's a simpler circuit. And then I want to hook up that SG that's hooked up to that up to this one over here. So let's do this. I'm going to turn the power off. Twist the knob all the way. Take the SG. We'll double hook it up on this coil over here that's hooked up to see if we can't get a little bit more power going through this. So we got both the SGs hooked up parallel to that one coil. And they'll both be dumping into this one SG over here. Now, this is where my brain kind of shuts off as to how we're going to hook the output now the ground one. I don't know, do we really need it? I think we do. It is all this circuit is hooked up to the same power supply, so. All right, here we go. Onward. We're gonna keep it kind of low. So I'd say it works, but it doesn't work. It needs to be stabilized underneath there. I need to put it on a mounting block. But that's gonna, I can't express enough how just this little extra piece right here, even though it'll slow it down a little bit, I think the voltage that it generates compensates at least for that. So it's a give and take. It might just be, end up being totally useless, and that's fine. At least that one anyway. I like the idea. I'm gonna grab a pickup coil of some kind real quick. Now, just for uniformity, I'm gonna have to hook up one of these bridge rectifiers. I don't know. We'll have to see. I don't want to glue it down. I really don't. until I can get something. Maybe I put, this will probably work a lot better. I put the turbine in the motor, like directly. Yeah, that'll probably work better. But will it fit? I don't think it'll fit in underneath the table that way. That definitely would be better. Hey Bob, what's up? This is Papa Bale's Pulse Motor Mayhem. We're looking at all different kinds of pulse motors and DC motors. Currently, I'm working with a DC motor. It's underneath the table here. It's the only one I got, but it works pretty good. Now let me grab my DC rectifier. Now I don't know if it'll work this way, but it should. So the AC will go in these two diagonal from each other and facing the same direction. And I'm pretty sure it doesn't matter exactly, but this is the end of the coil, and this is the beginning where it started. I don't know if it matters, but I put the one where it started next to the positive and the one where it ends across from the other terminal, the ground. All right, now the multimeter. Oh, dude. So we know about how much this one generates. At the speed we're going to use it at about 25 to 20 volts DC. And we are going to now hook these up to that bridge rectifier over there. We're going to see now how much DC voltage we're going to get off of this coil. Man, I wish it was stabilized now. I just don't know. I don't really know how. I don't have the engineering mind to figure that out. I have a bracket already. It's got to be in a certain spot, and I don't have anything like attached the bracket to. I mean, it's going to attach to this table somehow, but it's not going to be that simple. I mean, I can screw it into a piece of lumber, just a piece of lumber, but then, well, we'll start there. All right. What's up, my man? Who's there? Hey.
Remove this battery.
What do you need?
Controller. Again.
There you go. Oh, you okay? There you go. All right. Sweet. All right. VR is cool. Anybody have VR? this on. Oh, we're getting no reading. There we go. All right. There might be something wrong with my bridge. Because when I plug in, when we do it this way, either there's something wrong with the bridge or there's something wrong with the multimeter. Oh, I hope both of those are wrong, actually. So we're going to check AC. Well, actually, I kind of hope that the bridge rectifier is broken. We might have to get it in close. That might be what the issue is. So that should have a field at least that long. All right, that's more like it. Switch it to AC. Yeah, there it goes. 18, 19, 21. Let's say call that 35 volts. So, and then now I'm going to move the coil over to the pulse motor. The pulse motor is going to generate way more for this experiment. I just have a feeling. For a few reasons. One, the magnets are like extremely, they're better, stronger, have a wider field, they have a stronger field, they're just better. Yep, and like that, boom. We don't want it to be too far away. We don't want it to be too close either. So that's still affected at that distance. We'll see what we can do. The cord is sticking out. And now just pushing the core back in changed everything. Alright, let's see what we can do. Alright, so what was the, I don't even remember the voltage. I think it was right around 4 volts. 4.7 we'll call it. We got 35 on that? Yeah, it's not. It's already below that. 32. But that's pretty dang close. That's pretty good for a pulse motor at like 4.9 and 0.1 amps. It's pretty good. And look at the air gap we got. I mean, that's pretty good. Now it's 43, 42, 42 volts. But now let's turn it up to a standard battery of 9 volt strength. $75 volts. But I'm telling you, 9 volts into that DC motor, we'd be going like 2,000 RPMs. Just need to get it like a, I don't even know, I think the shaft might even be bent. That might be what the problem is. So 78, 79, 80, 81, 83. See, I'm inching it in there. 105, 106. See, if we get it in even there, but every time it slows down, it's gonna go like, you know, it's gonna be real messy. Just because of how I'm doing it. I mean, if I had like a strap, I'm thinking about it, like something you could strap it down in and just stick to one dimensional rotor. Like one dimension, what I mean is like 8 inches. And if you're going to do an 8-inch rotor, then all your rotors are going to be 8 inches for this particular shaft. And then you could put something, attach it to the table, and then have a strap attached to that. And I mean, you could even put it on a slider, and then you could change the size of the rotor. And I'm just thinking, I don't want to I want to get that right the first time. So I got to really put some thought into it, and I've been collecting data for that project specifically. And Gorilla Glue is going to be really mad at me for getting rid of the glue, man. Yeah, but I think it's going to be, a necessary step. And moving forward here, we're just getting rid of all the glue. Then it won't look so patchy, and just moving ahead. It's kind of old school using all the glue like that. And what I mean by that is kindergarten or first grade with the paste and everything. We're still generating a lot. 27 volts way out there. And that's at 9 volts in. $30 volts. Going to a 12 volt battery now. 12.2 volts in, 1.3 amps, 1.2 amps. I think it's beautiful, so easy. And the gyroscope was the thing that, kind of like turned me on, the gyroscopic pulse motor. does what it does, and all you have to do is turn it on. I mean, you really don't have to do anything. It's gonna do this no matter what, and that's cool. Um, oh, it did. It did. That's what it did when I built my first two. I guess it just functioned the way it was supposed to. It made me think that, you know, maybe these things function this way in nature, and you really can't like force it to happen or will it to happen. I mean, you might think that's what's going on, but it's really just happening. You know what I'm getting at? It's like, wow, wow. But it's already like, and it's just, but yeah, you know? I've seen a lot of awesome things, and I seek to have it be explained to me what's really going on. Explain to me what's going on, you know? Like, you now explain to me why it is this way, but I see it this way. Can you explain to me why I see it this way? Because if you can, then you realize what my point of view is, and that's kind of important when you're having a conversation. And I appreciate people's points of view, including most of all like myself, when I'm ignorant about something and I express my point of view on it, that can't be real. That is, you know, I express what I know. Like all this right here, it's not SG because it's in reverse. It's backwards. It's inspired by SG. That's the appropriate terminology here. I mean, the circuitry all might be the same, but it's on the end instead of at the beginning. So like the power supply goes into the coil first with all this stuff. And you get that extra resistance and everything. I don't know, that's just how I was taught how to do it, that the coil was the heart of the motor. And the coil comes first. But now I've learned over time that there's other ways to do it. You can hook up the transistor first, send the power through the transistor first, and then have it come out the coil to the ground. And I'm gonna hook up a motor that way for my first time here. I bought a couple circuits, SG circuit, generator combo circuits from K Energy, and I'm gonna hook those up. I'm gonna figure out exactly which rotor, you know, I'm gonna design the motor from the ground up, and we'll see how it goes from there. We'll use those two SG generator combo boards, and yeah, I will then officially hook up my first, when the two batteries get here, I'll hook up my first SG machine, I guess. Lightness of an SG machine. I don't like reading. Dude, I do not like to read. It hurts my head. There's no pleasure or enjoyment in it for me. If it's real important, I'll have like an AI read it to me. But that's the extent of how much I like to read. And life has been pretty frustrating because I'm eager to learn, but I'm not eager to read. So that's been pretty challenging living here on Earth, because everybody wants to write stuff down and think that they're, you know, teaching me something. I prefer either doing it myself or doing it with somebody that's enthused about what they're doing. It's not a job or work. You know, they really like it and they appreciate it. And when they do that, they respect it to the point where, you know, they keep it real. They keep it real, man. That's what they do. And in this field, keeping it real is real important because everybody's well, not everybody, I can't say everybody, man, it's really split, but there are people out there that don't believe in any of this stuff, think it's, you know, but, you know, I think it's not harmless. This right here, if I touch the wrong thing right now, could kill me instantly. And then I know that. So I don't touch stuff. You know, I've been shocked like 4 times with amps and volts, and it sucks. It really does. So, you know, like the next motor that I build with the 2 SGs is going to be safe too. I'm going to have to put all this stuff away, you know, because it isn't safe. I mean, I'll probably commandeer all the magnets, reuse those somehow. But, yeah, and it's going to suck, man, because my hands are really, you know, I shake a lot, and it's not a sturdy thing. I'm going to have to use that shrink stuff on all my ends, just to make sure that nothing is, you know, going to shock me or anybody else if it ends up, you know, being on display or something somewhere, somehow, and, you know, it doesn't look pristine. It's not even, it's just a pipe dream, you know, and it wasn't even, I'm not like suggesting something like that would happen, because I personally know that these, for example, wouldn't. But if I took my time and I put my effort into it, and my will was for me to make it look really, really good, and I would utilize what I have to make that happen. All right. So, yeah, I like this. This motor's moving now. Well, I'll just jump right to that. I mean, yeah, and then what I'm really trying to get rid of is all the shorts and all the instant connections that I do that make the amps go up to 20 and everything. You know, I don't need that happening. I don't need like the circuit to be perma closed. You know what I mean? There's a lot of switching going on right now, and usually it's normally open. So when it stops, the electricity isn't flowing through. So it's normally open. But if it's stuck closed and it's on, then you're generating. You're gonna blow everything up, man. You gotta turn it off at that point. You gotta do it fast before you start a fire. All right, here's a question. Out of all the stuff on this board right here, what's the most likely to catch fire? Hi. Yeah, this one over here. Yeah, man. Right now, currently, I only have one coil. This coil set up, and it's moving the pulse motor. That's all I'm doing with it right now. But yeah, I'm gonna set up a generator, transformer / generator. Probably do it on both. All right, so I got some magnets in today. All right. Now I don't know if this is gonna work right now, but I've got here. Let me see if yeah, I'm in there. All right. Dollar and I we were working on this, and they're gyroing because there's these magnets are in these slots right here. I'm using them to face. So I'm gonna see if it'll work now. And then I got a light rotor that I might want to check out in the center. Oh, that's sweet. I think that might even work. This rotor, I think, is an accomplishment. It's a 100% infill, and as of right now, all the magnets fit and everything works, and it's very smooth, very balanced, very, I would say it's heavy for PET-G. It's very good. Just altogether print and design. Oh yeah, I want to get this one off. This one is powerful. So, and this, if you were watching me when I had my permanent magnet sculpture first layer done, I gotta really find something that I want to have work. Okay. I did not realize that I had removed that. So I just need to find. There, this will work. See, so now there's a something for the thing to rest on, the rotor. I don't have a magnet for this to go for the maglev, but you know, I don't need to. I don't even know if I'd want to. I'd probably be resting way above the coil, and I don't want that. All right, let's check it out. That one's on. That one's on too. Oh, it's working. Oh. Now we can start adding different pressures. I hope it continues to work. What's going on with this one? All right, so now it looks like there's something's leaking. But if it was functioning properly, it would look like this. Currently, this one, we can mess around with that one. We want to try and get the gyro spinning, gyroscopic magnet holders. We're going to try permanent magnets and electromags. I think we're going to run all parallel circuits on this. I think that would be the best way to do it. So that's 9 transistors. And that way, when a magnet gets triggered by the gyro, it will pulse on the gyro. Any coil. Man. What the beef? What the... Right. Well... If anybody has any design ideas for me on how I can stop so I have an idea like this. This will be for a 12 magnet rotor slot, so it'll be for 2, 3, 4, 6, and 12. Okay, and then we got 8 and 10. That would have to be... See, there's so many different things that I want to do and be able to do. So, not only would these sliders have to be able to slide in and out like this, to make it so you can put bigger and smaller rotors on, but shift sideways along the circular diameter of the rotor, or triangular, whatever shape your rotor is. And see, that's the thing too, it's going to be really hard to come up with something that's practical and encompasses everything you need to be able to do in regard to positioning. And incorporate my will or desire to do something new and different every day, basically. So, I mean, that's why I think having too many like goals in regards to what I'm going to do with this stuff slows me down. And I mean, like if I'm going to have an idea for a motor, I usually build it until it's built, but I'm not even going to start building this next one until I have a lot more stuff gathered up from, information. We're just going to drop it down there with that magnet. There we go. Now this one does have a maglev, so that's how we deal with that. Bada boom. All right. Did you hear how it was all chunky? I started it at 12 volts, and that's why it was all chunky. I moved it down to 9, basically. And there, that's moving a lot better now. So ultimately, I believe that all of these coils will have their own transistor, and we'll see what happens. I used to build things like that all the time. I had 10 transistors hooked up to one coil because it was a 10 file coil. I can kind of feel it. It's really faint though. Try moving it a little closer, see what happens. I mean, it's right up on there, but and according to me, that's just how well it spins. It's still spinning off my finger, but I'm pretty sure that's wrong. That looks like it's moving actually. "12 volts, 1.1 amps. The light is bright. 100 watt light bulb right there. 100 volts to 277 AC volts. "100 watt, equivalent to 1,000 watt metal halide bulb." So that's, I guess, what it's supposed to be replacing as an LED. Yeah, this is slowing down. So I'm gonna need to make 4 coils that have extraordinary magnetic fields. I'm gonna have to do my homework on that too. I make a lot of coils, but they're all small. I think these ones need to be a little bit bigger, and probably about a 22-20 thickness in the gauge, with 30 to 32 trigger strands. And then I need the proper magnets. I think these magnets are too not strong. No, they're working. Okay, I just unplugged one of the SGs, and the light went out. What about this other one here? Make sure everything's functioning still. Looks that way. Okay. So the light will not turn on without both SGs hooked up to this coil. So I think that motor and that rotor is going to be a totally separate unit with its own power and everything else, man, because this is not going to be connected. I'm not going to run it with SG. Because just based on what's going on right here, it's not what's going to happen. But I do want to mess around with the perm magnets a little bit. So I'm going to go grab those. I'll be right back. I am going to need And I think I'm going to need to run these with PNPs if that's going to be possible. To have them all be PNPs, all 9 of them. Alright, so I don't know. So what I'm doing here is I'm making it north. It's going to be all north, facing the gyro. And I'll show you exactly what it is that I'm doing in just a second. I'm just and I'm gonna want to write this down, so I will Have to get my notebook before I take this apart and catalog exactly what experiment this is in regards to this rotor. I don't know. Alright, so all these stacks are facing north in towards the gyro. So what it does is when you spin it, it spins. So that's cool. I like that. But the thing is, man, I bought 20 of these magnets, $30. So I'll never be able to like fill all those in. But just thinking about if there's any more that I could do. You know? I think I have an idea how they can all get some love. Oh. Let's keep it uniform though, and I'll see how much of this I can actually fill in. So that's the south. So we're going to use south for that whole gyro. Wow, it is really strong, like, but it's spinning it. And then this one's spinning too, but it's spinning south. And then these four that are facing out, like right here, 1, 2, 3, 4, they're all facing north out. So let's see what happens. Because that's going to be balanced. I mean, it might shake the table, but Yeah, that's really unstable. But it's a work in progress. Let's just put it that way. Whip with fashion. All right. I like it though. It's getting heavier and heavier. That's good too. We'll try this bad boy over here. It's definitely making some noise. Sweet. I like it. These two, I like these two together. I hope that one continues to move. Oh yeah, it's good. I like it. What are we looking at? Well, let's turn on AC generator. We're generating 28 volts off of this coil, and it's probably all coming from this pulse motor. But I had a longer core in there, and it was about yay long, and the coil was in the middle, and I was getting about 18 volts off of both pulse motors at the same time. They might have been, and the reason I know it was working is because these are north face magnets on this one, and it would be attracted north face, and these were north too. So when this would line up magnetically, and this one would repel, it would be in between. And I guess it really all depended on which magnet got there first. I could get that core out. I could get it out, and we could see that experiment. Maybe not today. Maybe not today. But I think that would be sweet. And then I believe that we can put more and more coils, maybe little pickup coils on that core. See, I think that's working, and it is lacking severely. I can really feel that pulse though. That's good. With 12 volts and 1.1 amps going in, but I can feel it now. I'll hold the rotor there. But the frequency is like, maybe something I want to find out on this one so I can match it with a signal generator. I think it already is matched, honestly, through the SG. I think the pulse that's going through there is the frequency of this motor, and vice versa, maybe. I don't know if it goes backwards. I don't think it does because of the diodes. But that's way too fast. It's way different speeds here. That's it. Yeah. Oh no, we already did that. It didn't work out very well for that one. That's unfortunate because that one was running really good the other day. But then I had to move all these coils. When I had little baby pulse motor in the middle, I had them in the middle, and I was running it as a pulse motor. That one right there, the little plus. I had this whole thing in the center. But I guess ultimately, when you got too many things going on, you lose track of what's going on. So that's definitely working, but it's not working very well. That's a 22 gauge coil with 666 turns in each one of those coils. I know it can get things going faster than that. So ultimately, we're going to put this one in the middle, I think. Alright, we're going to need the other magnet. That. I'm glad that happened now. So 6 magnet rotor, 4 magnet rotor. That's beautiful. I would like to see how fast that is going. There we go. $703. Heck yeah, man, this is awesome. And this one's working. I think that black one's found a home. Yeah. What are we gonna call that? I don't know. Just call it pulse motor. Call it Big Papa. That's what we're gonna call it. $1486.91, 1500 divided by 4. So right around 400 maybe. 350. 714. And see, this one's only generating 17 volts off of the coil in the center here. That's awesome. And it's right in my, what do you call it, my safety zone. It's not much above 700. Let's see here, I'm going to turn it up though. We're at 1.7 amps at 13.8 volts. $737. $15 volts, 2 amps, 30 watts in. $742. $742.9. Awesome. I love it when everything is working. That is a plus. love how quiet this one is. It's so like balanced and nice that it doesn't make any noise really, except for the fan noise that it makes, the wind blowing. So I got a suggestion for a transformer, build a transformer, and I can do that. I gotta think though about what exactly I want to do. That's pretty vague, but it is a good idea. I want to hook up at least three more drive coils, or two more. So this one and this one, and then we'll have this one. And it doesn't matter how many magnets are in the rotor when you run them in, like consecutively like that, because they're not all hitting at the same time. They're hitting one after another. So it doesn't matter really. They all mishmash because you're not trying to have them all hit at the same time. And I don't know if that helps or hinders, but it is a way to set it up, so I'm going to do it that way. And then I was, considering having all of these, but the rest of them are 26 gauge and 30 gauge. So, yeah, I'm not exactly sure how that's going to work, but we're going to do it. We're going to start with 3. We're going to work our way up to a total of 9 drive coils. And how we're going to do that, I don't know exactly. What I'm going to try and do is I'm going to take this SG and I'm going to plug it into this SG's, I'm going to plug it into this coil. Okay, that's how I'm going to do it. I don't know if that'll work or not. We will see. I know it can't go back into itself because that doesn't work, but this is not it going back into itself. It's more of like a cascading series circuit. But yeah, that's how we're going to do it, and we'll know by the second one whether or not it's going to work. Alright, well, I'm going to get cracking on that. But I gotta take a break, get something to drink, and I'll relax for a few minutes. But I'll be back live probably in 2 hours, maybe 3. I'm gonna charge my phone and we'll get ready to go again. All right, but for now, peace out. Have a good night. Please subscribe, join the channel, like, and have a wonderful evening. See you later. Bye now.